So you should have watched the online lecture on free fall motion, and the equations were just the same as we've studied before. The only difference is that we are going to emphasize the y in them, and so we have that v final y equals v initial y plus a y t. We have that delta y equals the initial y velocity times t plus 1/2 a y t squared, and we have that v final y squared equals v initial y squared plus 2a y delta y. So the equations should look familiar. We just added a bunch of y subscripts. And the other thing that we always know is that ay, the vertical acceleration, is always just the value of gravity, which is 9.8 meters per second squared. And the other thing we have to keep in mind is that moving up is positive and moving down is negative. So I just want to go through a couple of examples with you on practicing these equations. And so these are actually coming from your Haiku PowerPoint, and I'm just going to do them here on the screen for you. So this first one says that a ball is thrown upward with a velocity of 5 meters per second. How long does it take the ball to reach its maximum height? How far up does it reach? How long does it come back down? And then what's the final velocity of the ball when it comes back? So let's go ahead and start off with some of the things that you know. So it's thrown upward with a velocity of 5. So what that means is that the initial velocity is a positive 5 meters per second. And that's all it's blatantly told to you, but again, remember, we always know the acceleration. Vertical acceleration is always negative 9.8 meters per second squared. And then the other thing that we know is that we're going to find out how long does it take the ball to reach its maximum height. We know at the tippy top of its path, the final velocity is 0. I guess I should put some y's here. So if I'm trying to find how long it takes to get to the top, and let's put that at maximum height. If I'm trying to find the time to go up, I'm going to use that maximum height value. And I can look at my equations, and the one that has initial y, acceleration, and final y, and t is the first equation that says that v final is equal to v initial plus a t. Again, let me put my y's in there. So my final velocity is 0, my initial is 5, plus negative 9.8 t. So take a moment, you can pause the video to solve for t. And when you calculate out t, t comes out to be 0.51 seconds. The second part says how far up. So that's what I need to know. What is delta y maximum? So there's two equations I could use to figure out what my delta y maximum is, because there's two equations that have delta y. The second equation says delta y is equal to v initial yt plus 1/2 a yt squared. And the third equation says that v final y squared equals v initial y squared plus 2ay delta y. They both have delta y in them, so it doesn't matter which one we use. So go ahead and pick which one you want to use and plug the values in. I'm going to solve both of them so you can see. So if I look at this first one, initial velocity of 5, my time I found is 0.51 plus 1/2 negative 9.8 0.51 squared. Or I could use the second one. At the tippy top, my final velocity is 0, my initial velocity is 5, 2 times negative 9.8 delta y. Either equation is going to get you a delta y value of 1.28 meters. Okay, next part. How long does it take to come back down? This is more of just of a conceptual question. We shouldn't have to calculate anything. We know that if my ball starts up and it has a velocity of 5 meters per second and it goes up, up here it has a final velocity of 0, and then on its way back down, I'm going to draw it over here. On its way back down, we know down here it's going to have a final y velocity at the bottom of -5 meters per second, and the time to come back down should just be the exact same as the time to go up, so the time to go down will be 0.51 seconds. Okay, so let's try another example of this, a little different this time. It says, suppose the ball, hold on, let me get there. Suppose the ball was thrown down, that's key, thrown down 125 meters with a velocity of 5 meters per second per building. What would the ball's final velocity be? How long would it take to the ground? So again, we're going to start off with our knowns. So take a moment and pause the video and try to find out, there's a couple things that we know. So try to identify what these quantities are and try to figure out if they should be positive or negative. So pause the video if you need to, and try to determine those things. So hopefully you have found that the delta y is negative 125 meters, and I'm going to put a little note that it's negative because moving down. Hopefully you realize the velocity initial was negative 5 meters per second, and again that applies to both my delta y and my initial y velocity, and acceleration for the y is always negative 9.8 meters per second squared. So in this case, all those quantities are negative. The question says, what would the ball's final velocity be? So the things I'm trying to find are what is v final, and then how long. So what is the time for that? So the first thing I'm going to do is I'm going to look for an equation that has delta y, initial y, ay, and v final, and that would be the third equation. The third equation says that v final y squared equals v initial y squared plus 2 ay delta y. So I'm looking for v final y, so v final y squared equals -5 quantity squared plus 2 times negative 9.8 times my delta y of negative 125. So a couple of things to just mathematically know: when you square a negative number, that becomes a positive value, and when you multiply this negative times negative, again, that's going to become a positive value. So we end up with looking at v final y squared equaling 247.5, and we're going to have to take the square root of that. So pause the video for that. Oh, no, actually it's 2475. That's a mirror. 2,475. Let me just go through that. I lost my 5. So this is going to be 25. And then when I do 2 times 9.8 times 125, that gives me 2450, which is going to be v final y squared is going to equal 2475. We're going to root for the home team, and that's going to be v final y is equal to plus or minus, what is it, 49.75. So remember, when you take the square root of a number, you're always going to get plus or minus. And so you have to ask yourself, which one is it? So think about how this ball is moving. It's moving downward, so that means my final velocity should be downwards, which is going to mean a negative. So I'm going to put a little note there to myself. Negative because moving down. So in a test or a quiz, you have to know to make that a negative. And the last part says how long would it take to hit the ground. So we're looking for time. The first and the second equation have time in them, but the first one is definitely a lot easier to use. So if I look at that equation, My final y velocity, I found that to be negative 49.75 is equal to my initial velocity of negative 5 plus negative 9.8 times t. And take a moment, solve for t. Pause the video if you need to pause the video. And the time comes out to be 4.57 seconds. So that's my final answer. Okay, let's try one last example. And for this one, it says, suppose a squirrel throws a walnut from the top of a 111-meter tall giant redwood. If the walnut takes 3.8 seconds to fall, what is the initial and final velocity? So this is how high it is, so that means that must be the delta y. But keep in mind, the walnut falls downwards, so this is going to be negative 111 meters. So if we kind of had like a little visual of this, here's my tree. It's a redwood, so it's really tall and skinny and bendy. And there's my little squirrel dropping this thing. So here is, oh, and look at it, he's not dropping it. Here's another key phrase. He's throwing it. It's like an evil little squirrel. He's definitely this is not to scale. He's throwing it with an initial velocity. And it's moving down this delta y distance of 111 meters. Okay? So in terms of the things I know delta y is equal to negative 111 meters. I know my acceleration is always negative 9.8 meters per second squared. And I know the time it takes to fall is 3.8. And I'm trying to find my initial y velocity and my final y velocity. And just some things that I should keep in mind, I should think about. These should be negative because it's moving downwards. Okay. Okay, so let's look at what I know. I know delta y, acceleration, and time, and I'm trying to find the initial velocity. So what equation has those three quantities? That would be the second one, delta y is equal to the initial y velocity times time plus 1/2 AYT squared. So let's plug in what I got. Negative 111 is equal to initial y times 3.8 plus 1/2 times negative 9.8 times 3.8 squared. And now it becomes a matter of kind of solving for your knowns. And some of you, again, are really handy with your calculator. You can do this in one fell swoop. I'm going to do it in some steps to make sure we're keeping track of our order of operations. So the first thing I'm going to do is I'm going to multiply out. Ooh, let's use the highlighter. No, that's just really big. I'm just going to use a normal pen. I am going to multiply out all of that. Okay? So I'm going to keep this as the initial y times 3.8, and when I multiply out 1/2 times negative 9.8 times 3.8 squared, I get something like negative 70.756. Okay? And what I have to do now is I have to add that to both sides, because I want to get the initial y all by itself. And when I do that, I am going to get on this side negative 40.244 equals 3.8 times the initial y. And my last step is to divide both sides by 3.8. So go ahead and solve for the initial y velocity. Let's see what you get. And you should get that it's negative 10.59 meters per second. And that agrees. We should be getting a negative value because this evil little squirrel is throwing it downwards. Okay, last part of the problem. It says, what is the final velocity? So now that I have my initial velocity, to find my final velocity, I'm just going to use the first equation that says that v final is equal to v initial plus AYT. And I know my initial velocity, it's negative 10.59, plus my acceleration is always negative 9.8, and my time is still 3.8. Okay, so take a moment, write that out, calculate that out, and see what you get. And hopefully you get that your final y velocity is negative 47.83 meters per second. And again, that agrees because it's a negative value. My final velocity should be negative. Okay? So at this point, you should be able to work on some of the examples by yourself. So when the video is done, you are going to get the practice problems, the free fall practice problems, and work on those for the remainder of the time.